In this series of videos, we will be documenting the build of my brother-in-law Nick's all-wheel drive K-Series swap 93 Civic hatch. My overall intent of this build is focused on ending up with a nice driver that can be competitive at the track without breaking the bank account. However, I know Nick's intent is to build a car that will outrun my Cadillac in the quarter mile. We are still several videos away to see if this will happen. Nick bought this hatch in rough shape for about $500. So the first order of business was to blow this car apart for a seemingly endless amount of bodywork, then off to paint at a friend's shop for a fresh coat of blue. To begin the all-wheel drive conversion, we decided to start with the rear trailing arms. As far as I know, there is no direct swap for all-wheel drive applications. So we started by sourcing used trailing arms from a 94 Integra to modify to accept rear axles. The factory hubs must be removed, and since these trailing arm bushings are worn out, we decided to add spherical trailing arm bushings. Removal of the factory hub is pretty straightforward. Anytime you attempt to bust bolts loose from an assembly that has seen use, it helps to soak the bolts in penetrating oil. Usually worn trailing arm bushings can be removed easily. Begin by using a hammer to knock out the center of the bushing. Once the center is removed, you may have to cut the remainder of the bushing with a saw. After this cut, the tension will be relieved, and the rest of the bushing can be knocked out with a hammer. The spherical bushings do not install in the same way as the factory bushings. The factory bushings press in, but you must drill bolt holes to mount the aftermarket spherical bushings. This kit includes a metal template that can be used to locate the holes that must be drilled. Start by placing the template onto the trailing arm and drilling 1/8" pilot holes. Once the pilot holes are drilled, 3/8 holes can be drilled for the bushings mounting hardware. Once the trailing arms have been stripped and pre-drilled for the new bushings, this is a good time to clean the arms and prep for the rest of the modifications. Next, adapter plates must be installed. These plates will allow for the use of Honda Insight front hubs and Integra rear disc brake calipers. 2 of the 4 holes in the adapter plates will line up with the factory hub mounting holes in the trailing arms. One of the holes must be drilled through the trailing arm. The remaining hole will allow the hub to bolt directly to the adapter plate without the bolt going through the factory trailing arm assembly. Now, the trailing arms need to be cut to allow the axle to mate with the wheel hub. A 2.5" hole saw works good for this. Even though the 2.5" hole has been cut, the inner section of the trailing arm will interfere with the axle, so this section must be modified. Start by removing the metal on the inner section of the trailing arm to allow the axle a path to the wheel hub. Then remove the section along the rear of the trailing arm that curves inward towards where the axle will be. Once the trailing arm is stripped down and notched, it's time to prep what's left of it for reassembly. There will be a decent amount of welding that needs to be done, so the areas that the adapter plate will be welded to should be cleaned down to ensure a good weld. Since so much metal has been removed for axle clearance, some needs to be replaced. We decided to use some leftover fence posts that we had been using for a breaker bar. Once the metal was cut and given the initial shape by hammering it out on the bench vise, we placed the metal onto the trailing arm to fine-tune the shape and curve of the metal that will box in the rear of the trailing arm. After the metal is shaped for the rear of the trailing arm, take a quick look to ensure there will be no interference once the axle is installed. Now, it's time to weld the reshaped portion of the trailing arm and the adapter plates to the trailing arm assembly. With less than a $400 investment, a few hours labor, a fresh coat of paint, and the hub and bushings installed, these trailing arms are a nice starting point for the all-wheel drive conversion. For any car to be all-wheel drive, the rear wheels must spin. In our case, for this to happen, we will need to add a rear differential. This kit will be able to provide mounting locations for a first-generation CR-V rear differential. Since this car never came with a rear differential, it is no surprise there will be a few modifications needed before we can mount the rear differential. A section of the subframe must be removed. The aluminum rear support bracket fastens to the existing holes in the subframe, but will need holes drilled in the floor pan so the vertical support bolts can be installed. Once the rear diff mount bracket is installed, the bolts can be tightened. This will locate the differential so a relief cut can be made in the floor pan bump out for clearance. Once the section of the subframe is removed, A part of the spare tire well is the next obstacle. We marked the area of interference and made 2 cuts from front to rear so the section in between the cuts can be raised and a bump out created with minimal cutting and welding. To begin the rest of the differential mock-up, bolt the bracket supplied with the kit to the rear of the CRV differential. With room created under the car and the rear diff mount in place, the front mount must be installed. This mount is a cross brace supported by the subframe. Start by welding the brace mounting plates to the subframe. Place the upper cross brace on top of the differential. This brace may have to be cut for a snug fit in between the mounting plates. Once this brace is in place, tack weld it to the upper differential mounting bracket. The cross brace can now be welded to the front mounting bracket. With the differential supported, the cross brace must now be welded to the support plates installed earlier. With the bump out section exposed, it is easy to tighten up the upper diff mount bolts, but holes directly above these bolt heads have been drilled to give access. Once the bump out is shaped and welded back together, a quick coat of undercoating was applied to eliminate opportunities for rust. Since we could not easily get our hands on a rear differential from a Civic wagon, some modifications had to be made to the CRV diff. Start by removing the case and all of the old fluid. We decided to remove and discard the fluid pump. We would rather fill this area with fluid since the clutch pack will be locked. There appeared to be a breakaway point on the input shaft that we felt must be eliminated. Once the breakaway point is welded, place a tack weld on the clutch pack to keep the discs and plates aligned, while work is being done to pin the assembly. The clutch pack is being locked to allow better power transfer to the rear wheels. The power distribution between the front and rear axles will be controlled with a viscous coupler installed in the drive shaft, as opposed to the clutch pack in the factory CRV configuration. This eliminates the need for movement inside the clutch pack and fluid pump. Once the clutch pack is tack welded together for alignment and removed, drill 3 evenly spaced 1/4-inch holes through the clutch discs and plates. A drill press really helps with this, since the discs can be tough to drill. Install a 1/4-inch rod through the drilled holes to pin the clutch pack. Weld the pins flush with the surface. Cut the pins flush from the other side, and weld the pins flush on this side as well. Weld the pack plates together, and it is ready to reinstall. Reassembly is in reverse order of disassembly. Make sure all washers and rings are reinstalled, and take it easy on the gasket sealer. The last thing that has to be done to the rear diff is install the LSD grip plates, so the rear differential will act as if it is limited slip. To do this, you must have access to the rear gear set. Remove the gear case while making sure you keep track of where the shims are placed. These shims must be reinstalled in the same location. Tap out the tension pin and remove the ring gear bolts. Next, the cross pin that was held in place with the tension pin can be knocked out and removed. There will likely be some grinding required to allow the LSD grip plates to be installed. Once the grip plates will fit in between the side gears, reinstall the cross pin back into the gear set. After the grip plates are in place, remove the locking tabs and pins. It is important that these tabs do not come off until the grip plates are securely installed. The tension pin can now be tapped back into place once the hole in the cross pin is aligned. The ring gear can now be installed to the gear set. Make sure to torque the bolts in a star pattern to control stress on the ring gear and ensure it seats properly. The gear set can now be placed back into the differential housing. Make sure the shims are placed in the same locations as they were removed. This will reduce noise and premature failure. Reinstall the differential case. A small amount of RTV should be used to prevent leaks. Tighten the case and reinstall the unit back underneath the car. Be sure to get the rear and upper diff mounting bolts tight. Offset lower control arms will be needed for the axles to clear the suspension. Passenger side rear axles from a 98 to 01 CRV are the correct length to be able to center the differential on this setup. Factory EG brake lines and Integra emergency brake cables will be used to complete the conversion in the rear.